Hello, this is Mr. Wen, and today's video will be about solving exponential equations and inequalities. So, let's look at this property of equality for exponential functions. It says you have two of the same base, for example b, and they're equal to each other. That means their exponents are also the same. So for example, if these two bottoms are the same, 3 and 3, and they're equal to each other, the sign in the middle, well then the exponents have to be the same as well. So we set x equal to 5. So 3 to the 5th equals 3 to the 5th. So basically I'm going to say that means same bases, so same bottoms means same exponent, same tops. So let's look at example 1. We have 2 to the x power equals 8 to the third power. Now they do not have the same bases, but we can rewrite one of them. So is it easier to turn 2 into 8 or 8 into 2? Well, it's easier to turn 8 into 2. Because we should know that 8 is a perfect cube. 8 is really 2 cubed. Alright, so inside the parentheses is still technically 8, because 2 times 2 is 4 times 2 is 8. Now we have to use our exponent rules or properties. This is power to the power, so this would be, I'm going to multiply these, I'm going to distribute that exponent, that's going to be 2 to the 9th power. Well, now you see we have bases of 2, the same bottoms, that means we have the same tops. I'm going to set the exponents equal, so I have x equals 9, and that's it. So we can check if I plug in. So if I do 2 to the x power, 9th power, I get that number. Well, that should be 8 to the third power. Same thing. Right over here, same idea. I do not have the same bases. Now, is it easier to turn 3 to 9 or 9 to 3? Well, we know 9 is really just 3 squared. So let's fix this 9 and change it to 3 squared. So that's 9 and leave this out here the same. Alright, now I do power to the power. I can multiply this. So that's really 3 to the 4x minus 2 equals 3 to the 6x. We have same bases, 3 and 3. We have the same exponents at the top. So really, so the exponents equal to each other. 4x minus 2 equals 6x. Now it's just regular algebra. So I'm going to subtract 4x. So negative 2 equals 2x. Divided by 2. I get x equals negative 1. And now let's plug it in and check. So 9 to the 2 times x was a negative 1 minus 1 gives me this decimal. Well, 3 to the 6 times negative 1 should be the same decimal, which it is. Alright, so again, just same bases mean same powers, same exponents. Inequalities are solved the exact same way. So instead of equal sign, we just keep whatever sign it says. So if I do same bases again, well, 16 and 8, 16 can't really turn to 8 by an exponent. But let's fix both sides. So in order to do that, we know 8 is 2 to the third power. Now 16 is 2 to the fourth power. Because 2 times 2 is 4, times 2 is 8, times 2 is 16. So I can rewrite both these as bases of 2. Again, the power to power, I'm going to multiply or distribute this to that. I have 2 to the 8x minus 12 is less than 2 cubed. Well, same bases means same exponents. I'll just ignore the bases. I basically have this new set of equations, the inequality. And I solve this. Because the left side exponent has to be lower than the right side exponent for this problem. So I'm going to add 12. So we're at 8x is less than 15. And then we're going to divide by 8. Alright, now that's a fraction. Let's leave it that way. There's our answer. Right, as long as x is less than 15 over 8, that inequality will always be true. Right, this works for any type of inequality, even if we have these signs with the equal part. Even if it's less than equal to and greater than or equal to. Alright, now I'll be able to write exponential equations. So Han, a girl, starts an experiment with 7,500 bacteria cells. After 4 hours, there's 23,000 cells. So first, let's find the exponential function. So it gave us exponential. Remember, our exponential equation looks like this if there's no h and k. So let's not worry about h and k. All right. A is a start. Do we know what we start with? Right here. We start with 7,500. So we're going to replace that A with 7,500. Now notice we're missing B. We're going to have to find it. So we find it by using another point. Well, it says after 4 hours there's 23,000 cells. That's the point. That's basically our first point is 0, 7,500. That's how much we start with. At time 0, we start with that much. And we have another point at time 4 hours in, we're at 23,000. So you see how that 23,000 is our new x and y? We can plug that in. So let's go over here and plug that in. So y is 23,000. That equals 7,500. B to the x power, well, x is 4. Well, now we just solve this by algebra. Remember, we have to get the letter b by itself, so divide both sides by 7,500. All right, use a calculator. So 23,000 divided by 7,500 is that. Let me turn to a fraction. 46 over 15. So it's 46 over 15 equals b to the 4th power. All right, and then I'm going to, well, I solve for b, I'm a 4th root both sides. All right, so let's find the 4th root of 46 over 15 is math 5 4th roots of our fraction over 15 gives me that. All right, so we found b. So b equals that fraction. Now the book was lazy, so they use a decimal. So let me turn it to a decimal. So math 2. That's about 1.323. So the book went 3 decimal places. So let's just use that approximation like the book. So b equals 323. 323. All you can do is replace that b in our equation. We're done. So let's put it back in over here. Y equals 7,500 times 1.323 to the x power. That is our equation. Right. So notice b is positive. I mean, it's above 1, so it's growth because the bacteria are growing. And how many cells are there after 12 hours? Well, that's our time, t, or our x. Using our equation, let's plug in that time of 12. 7,500 times 1.323, 12 hours. Let's plug in the calculator and see what we get. So, y equals 7,500 times 1.323 to the 12th power. 215,664. 215,664. And I'm not going to do half of bacteria. All right. So after 12 hours, 7,500 of them turn into 215,000 of them. So as you can see, bacteria grow really fast. All right. Another part of this, another exponential function that y'all do like is interest, money, loans. Exponential functions can be used in compound interest. Now, compound interest is interest paid on the original principal and on any interest extra that you earn. So this is not simple interest. Simple interest, you charge interest one time per year. Compound is interest on top of interest, which gets you even more interest, obviously. All right, here's the formula. You do not have to memorize it. I'd give it to y'all. But you need to know the vocabulary for n, because n is the number of times you compound it per year. All right. So if they say they compound it annually or yearly, that means n is 1. That's what simple interest is. But when they compound it biannually or semi-annually or semi-yearly, n is 2. If they compound it quarterly, there's 4 quarters, so n is 4. If they compound it monthly, there's 12 months, so n is 12. If they do bi-monthly, that's half a month. There's 24 of those because there's 2 half months each month. All right. Basically, if I give you interest annually, I mean, I just check interest one time. If I compound it biannually, I'm going to charge the interest twice. So for example, say somebody charges 10% interest annually. That means for 1 year, they charge you 10%. But the same person says, oh, I'll charge you 10% biannually, or 10% each year, but I'll compound it biannually. They're going to do 5% each half. They're going to do 5% after 6 months and then another 5% at the 12-month mark. And that'll actually earn them more money. All right, anyways, let's answer the problem. Investment account pays 4.2% annual interest, compounded monthly. All right, so that tells me what N is. N is 12. All right, there's $2,500 invested in the account. How much is there after 15 years? So, like before, that A is basically our Y. Y equals, I'm going to say P is our principal. How much we start with? This is the starting amount, which is $2,500. All right, then 1 plus R. R is our rate, our interest rate, as a decimal. So it's 4.2%. That's 0.042. Or just move the decimal twice to the left. Over N, monthly is 12. To the NT. N is 12. Time is T. It said 15 years. All you use type in calculator, you get your answer. So let me show you what happens here. If we do 2,500 times, so I'm going to clear that. 2,500 times 1 plus the fraction, 0.042 divided by N to the N times T. That money grows to 4,688.87. 4688.87. 4688.87. Alright, so after 15 years, this guy's money almost doubled, because double would be 5,000. Now, without writing, let me show you what happens if the N changes. Say instead of doing monthly, say they did bi-monthly, they did it 24 times per year. So that changes the bottom of the fraction, and this changes. Instead of getting 4,688, he gets $3 more. But if we're talking about bigger terms, that could be $3,000, $3 million, but it's more. All right. Basically, the more times you do it, I mean, there's technically a daily one as well. Say I do 365 times per year. Up here, let me put 365. So 365, he'll get even more money, $2 more. But the more times you compound it, the more time you charge interest or check interest, the more money the person will make. All right. So there's that. That should be it. So here's the practice problem. Solve for x. Remember, same basis, same powers. There's the answer. If you can do that, should be fine for class. Again, this is Mr. Wynn. Thanks for watching. See you in class. Bye.